Hello, today I'll talk about drawing Lewis diagram of molecules, but I will start with drawing Lewis diagram of atoms. As you see here, Lewis diagram of atoms shows the symbol of the atom surrounded by the number of valence electrons, and when you put these valence electrons, it should be following a pattern, it's not randomly. So around the symbol of the atom, you should imagine that you have a square, and on this square you should put the dots that are representing the number of valence electrons. On the first side of the square you can start with the first electron, and then for the second you should follow the clockwise direction. This is the second electron, then the third electron, then 4. If you have more than 4, you should follow again the clockwise direction, 5, 6, 7 and maximum 8 electrons. Oxygen is one example, so we are starting with 1, 2, 3, 4, 5 and 6. When drawing Lewis dot diagram of diatomic molecule, we can put between the two atoms one line which is representing a single covalent bond, 2 lines representing double covalent bond, 3 lines representing a triple covalent bond, and it depends on how many electrons the atom can share. We can decide which covalent bond we are putting. Now to draw the polyatomic molecule, it's a little different because it's following 5 steps. I will talk about each step, and I will give you 2 examples, which are H2O and CO2. Step 1, you should count the total valence electrons of the molecule that you have. For example, for H2O, hydrogen has only 1 valence electron, oxygen has 6. We have 2 hydrogens, so 1 times 2 equals 2 plus 6. The total valence electrons is 8. The total number of valence electrons for CO2 is 16 valence electrons. Now for step 2, we should choose, when we are drawing Lewis dot diagram of the molecule, we should choose which one is the central atom, and usually the central atom is the least electronegative. We should pay attention to this note. It's very important that hydrogen is never in the center, even if it has the lowest electronegativity. This is the periodic table of electronegativity showing H2O, because H is an exception, so O is in the center for sure. O is in the center surrounded by 2 hydrogen. Now for CO2, we have carbon here 2.5 and oxygen 3.5. Carbon is the least electronegative, so carbon in the middle surrounded by 2 oxygen. Let's go to step 3. In step 3, we should connect the atoms with a single bond, and we should calculate the number of remaining electrons. How we can do that? When we decided already that oxygen is in the middle, so we link the oxygen with a single covalent bond with the 2 hydrogen that we have. Here we are using 2 electrons, and here in this one we use 2 electrons. So to calculate the number of remaining electrons, we should have the number of total electrons minus the number of the electrons used here in the single covalent bond that we just drew. So here we are using in total 4 electrons, so we used 4 electrons. We had already 8 electrons. 8 minus 4 equal 4 remaining electrons. Same thing for CO2. The total number of electrons was 16. We used 4 in these 2 single covalent bonds. 16 minus 4 equal 12 electrons remaining. Now let's go to step 4. In step 4, we have to add the lone pairs that are around the atoms. So first of all, we have to place the lone pairs around the outside atoms, and we calculate again the number of electrons remaining. For H2O, we know that we have 4 remaining electrons. So we have 4 remaining electrons, but we cannot put any electron in the outer atoms because H is already stable, so the number of remaining electrons is still 4. Step 4 is done for H2O. Now let's talk about CO2. In CO2, Each oxygen needs 8 to be stable. Here we have already 2 because it's linked to the carbon. So we need to add 1, 2, 3, 4, 5, 6, 7, 8. So now oxygen is stable. For the second oxygen also, 1, 2, 3, 4, 5, 6, 7, 8. Now the second oxygen is also stable. How many electrons did we use in total when we are putting these lone pairs? We used the 12 electrons. And if you remember in the previous slide, we said that we have 12 electrons remaining. So we used these 12 electrons already. 12 minus 12 give us 0. But are we done yet for the CO2? Not yet, because no more electrons are remaining, but the carbon here is unstable, because also carbon needs 8 valence electrons to be stable, and here it has only 4 electrons. So carbon is unstable. We cannot leave this representation like this here. It's incorrect. We have to go to step 5. In step 5, we have to place any remaining electrons on the central atom. Now, for H2O, remember that we have 4 remaining electrons, so we need to put these 4 remaining electrons 2 by 2 as lone pairs around the central atom, which is oxygen. That's why we obtain 1, 2, 1, 2. This is the Lewis structure of H2O. It's correct. Oxygen is stable with 1, 2, 3, 4, 5, 6, 7, 8 electrons. Hydrogen is stable also. Now let's talk about CO2. We don't have any remaining electron. The central atom still does not have a full octet. As we already said, that carbon is still unstable. So we have to form double bond or triple bonds in this case by moving the lone pair into the bonding pair. So we decide to change this 2 lone pair into bonding pair. So we move them inside to as bonding pair to form a double bond here and a double bond here. Now in this case, oxygen is stable with 8 valence electrons. Carbon now is stable with 8 valence electrons, and the second oxygen is stable with 8 valence electrons. So this is how we draw the Lewis structure of H2O and CO2.